During the Industrial Revolution, tasks that were once done by humans were replaced by machine. A man named Joseph Marie Jacquard invented a way to automate weaving by programming the pattern he wanted woven onto a set of cards with holes punched into them. A punch caused the needle to go through the hole and raise a thread, and no hole would lower it. The difference engine was a mechanical calculator invented by Charles Babbage. It was composed of over 20,000 gears and parts that could be used to perform basic math problems with addition, subtraction, and multiplication. It was originally made for the use of doing the math for complex government charts, and Babbage built a small working model of it to prove that it worked, but he never ended up finishing the project. Babbage's second invention was much more complex than his first. It was a machine that was given its instructions through the form of punch cards and could solve complex mathematical equations. The Analytical Engine was also never built. It was a century ahead of its time, being very similar to the computers that were used during World War II. Ada Lovelace was a brilliant young countess who worked closely with Charles Babbage and was fascinated with his machines and their endless possibilities. She published a translation of an article on the Analytical Engine with her own notes in the margins, creating a program that the Analytical Engine could use for many different tasks, many more than had been thought of at the time, including very complex equations and even creating music. This is thought to be the first ever written computer program, and Ada Lovelace is considered to be the first ever computer programmer. Every 10 years, the U.S. government held a census to gather important information about the age, jobs, gender, and size of the population. It had taken almost 10 years to tabulate all of the information for the 1880 census by hand, so they were desperate to find a faster and more efficient method for the upcoming 1890 census. The government held a competition to find a faster way to tabulate the information. A young statistician named Herman Hollerith won, his machine being able to tabulate the information up to 10 times faster. People called clerks entered data on the cards that they would punch and then put into a machine that would read the cards. If there was a hole, then a wire would go through and drop into a pool of mercury, connecting an electrical circuit and adding information to certain dials that would record the information. Each dial represented a different data item. After the card was read, a small drawer would open in the sorting table, and the clerk would place it inside. Most of the clerks could process around 80 cards a minute. These types of tabulating machines were used all the way up to the 1950s. Herman Hollerith founded the Tabulating Machine Company that created tabulating machines for businesses. In 1924, it was renamed IBM. IBM was, and still is, an influential company in the world of computing. During World War II, radar was used to detect incoming enemy planes. A radio wave is sent out from an antenna, and when it comes into contact with the metal body of a plane, it will agitate the unstable electrons in the atom's outer shells and cause them to wiggle and produce their own electromagnetic field that can be detected by a receiver. Hollywood actress Hedy Lamarr came up with the idea of frequency hopping, a way to send radio signals so they could not be easily intercepted by constantly changing the frequency of the signal. Frequency hopping was going to be used by the Allies so they could pilot their torpedoes without the radio signal getting jammed by the enemy. Although in the end it was not implemented, today we use a version of frequency hopping in the Bluetooth and Wi-Fi on our cell phones. During the war, the UK built multiple Colossus computers to crack extremely complex German codes that had been written on Enigma machines. The Colossus computers weighed 5 tons and used vacuum tubes to turn the flow of electricity on and off. They were programmed by switches and dials, and they were fed punch tape with the encoded message on it that would move through the machine at 27 miles per hour. The U.S. also built their own computer, the Harvard Mark I, that was used for the war effort and Manhattan Project. It was programmed by Grace Hopper, who later invented the first computer compiler, which allowed written mathematical instructions to be easily translated into the language of computers, ones and zeros, or on and off. ENIAC was the first general-purpose computer. It filled a 100-foot room, weighed 30 tons, and had 18,000 vacuum tubes, and it was programmed by a group of 6 women. All of these computers I've mentioned ran on punch cards. Each punch card contained just one line of code, so each program ran on thousands and thousands of them, and if your cards got out of order, you were going to have a bad day. Up until 1958, computers were a mess of wires that connected vacuum tubes into huge circuits, which made them very big and slow because their components were so big, allowing for less to be packed together and thus less processing power. In 1958, the integrated circuit was invented, which is pretty much a computer chip. This allowed for wires to be thinly etched onto silicon and connected with transistors, which are much more compact than vacuum tubes, and do pretty much the same job, which allow computers to become smaller and much faster. NASA landed the first man on the moon by using the new cutting-edge technology of computer chips to make the computers on board the shuttle smaller and more powerful, allowing it to make the complex calculations in order to land safely on the moon, as well as over 400,000 brilliant workers and mathematicians that made everything possible. The first computer bug was a moth that literally flew into the computer hardware and caused it to malfunction. The computers that landed the first men on the moon were millions of times less powerful than an average cell phone.